Okay, lesson 29 is a takeoff of lesson 28, but we're going to solve the two variable real-life problems by graphing the equations this time. Okay, and here are our two equations that we modeled from the problem from the last lesson. Remember, A is the number of adults, C is the number of children. So the adults plus the children all combined to 2,200 people, and $7 per adult plus $3.50 per child came to $10,199. And again, this is from the last lesson, and it's the same circus problem that we had. Okay, now when we graph our linear equations, it's actually better to convert our variables to x and y values. So I'm going to go ahead and just assign x equals a and y equals c, and then rewrite these equations. Okay, and here are the new equations with the x and y variables, and we do this because whenever we graph, we almost always use the x-axis and the y-axis. All right, I'm just going to move these up here. Okay, so here are our same two equations, just with x and y variables. So to graph these now, we will make a table of ordered pairs like we did before, and randomly assign values to x and then see what the subsequent y value is. And we could go on, but I'm going to stop at 800. And you could see from this equation here, it's pretty simple to calculate what y is without solving algebraically. And also do the same for equation 2. Well, we will use the same x values that we assigned for equation 1. Now this one's not going to be as easy to calculate what y is, so I'm going to go ahead and solve for y so it's easier to calculate what y is with each of these x values. I'm just going to rearrange this. I like to have the x in front. It is proper etiquette. So this is our revised equation 2. And I'll put it there. So now I can punch in into our calculators in this equation here and more easily get the resulting value of y. Okay, and now we will go ahead and plot these. And I will pull in my graph paper again. And I will assign some values to the x and y axis. And a lot of times it's trial and error to figure out the right scale to use on your graph. I'm going to use 10, increments of 10 on the x-axis. I had to go off the graph a little bit there, but that's all right. Okay, and putting in the y-axis values, you can see our range is between 1,300 and 1,900 here, and the range here is less than that. So we will use equation 2's range as a guide. So we could start at 1,300 here. It is a bit of an art form to figure out the best increment sequence to use. Increments of 25 don't have enough vertical graph here, so I'm gonna use 50, increments of 50. All right, and let's go ahead and plot the ordered pairs. I will use red for equation 1's ordered pairs, 500 and 1,700. So x is 500, y is 1,700. And I will use blue for equation 2's ordered pairs. 1914 is going to be around in there. And I will attempt to draw straight lines for both of these. Okay, obviously I didn't do very well with the straight lines. This program I'm using to draw with does not allow it. So, but you kind of get the idea here. I mean, the red line is a little squiggly, but that's supposed to be straight. But the key is where they intersect. Where they intersect is the answer for x and y. And we see roughly, and this is a problem with graphing a solution, you're not going to get an exact number. So we're seeing it's a smidgen over 700 for x, is a little bit greater than 700, and y, it looks like it's just under 1500, so y is just under 1500. So that's going to be approximate. And that's how you graph the solution. So now, when you solve it algebraically, you saw that x equals 714, and that's what that right there is supposed to represent, and it's pretty close. And we know that y equals 1486, and that's what that point there is supposed to represent. So that's how you graph two linear equations using graphing the solution.